product I acquired called Nanocellulose. This is actually Cellulose Nanofibers, or CNF. They're ultra fine fibers, right, derived from basically from plant material and agricultural waste. And this is mostly water, believe it or not, right? The cellulose amount in it is very little. It's like 2% or 3% cellulose, and the rest is all water, right? It forms this gel that you can't even squeeze the water out of. That's how the cellulose absorbs the water. It has a high strength to it. It's even more durable and stronger than things like Japanese paper, right? So this stuff is typically produced through mechanical and chemical processing, and there is a special grinding methods they use to achieve these nanofibers, and they have exceptional strength. They give you a high surface area and a great deal of flexibility. So we can use them in conservation for reinforcing paper and for tear seals and things like that. But the methodology involved is a little bit tricky. It hasn't really been worked out very well yet. And I'm gonna show you different techniques we can use this stuff as an additive, if you will, a tool in our toolbox, right? For example, you can add it to your, as an additive to your furnish recipe. You can use it for tear seals in conjunction perhaps with methyl cellulose and wheat paste. You can even use it to reinforce the spine. You can use it for tear seals. So it has multiple applications. It has great physical properties in that it has a high strength. It is thermally stable, so you could actually freeze this stuff. You can buy a lot of it and freeze it if you're not going to use it. And it is just primarily made up of cellulose, just cellulose fibers. They measure in nanometers widthwise, but in micrometers lengthwise. So they are formidably strong fibers. So what I'm gonna do is make a dilution of this per recommendation, which is typically if you wanna make a 0.2% solution. This is already at 3%, 3 grams per 100 weight to volume, and you want to dilute this down to becoming 0.2%. So for this to occur, you will need about 7 milliliters of this, and then bring the volume up to 100 milliliters with water, right? And that will give you the concentration needed, which will give you at the end the desired solution that we need to work with. And that solution can be used for tear seals. I don't have methyl cellulose here in my lab here, but I'm gonna try it anyways and see how it works, just out of curiosity, right? So hold on for a second. Let me get my Archie wrap. I'll be right back. All right, so here's my Archie wrap, and you can see there is a tear in it. Pretty obvious, right? And this tear should be lined up well first before you do any repair, right? So let's make sure it's lined up. And this is gonna be on the inside like this. I believe so. Anyway, so this is fine. And I'm gonna use some of this stuff essentially to seal the tear and then put it in the press, right? So let's do this. I think this is gonna be this way. Is it? Yeah, I think so. We'll do the repair on this side, right? We'll do the repair on this side. Okay, so, and you can do it on both sides actually. There's no reason why you can't. All right, let's do this, guys. So I'm gonna start by spraying my Archie on both sides with water. And you can use calcium hydroxide if you'd like. And this is just a quick attempt at fixing this tear with cellulose nanofibrils, these ultra fine fibers that I got from University of Maine, and they are expensive. All right, so we're gonna let this saturate and then we're gonna flatten it and do the repair, right? Okay. Meanwhile, while this is sitting, I'm gonna go ahead and prepare my solution of the cellulose nanofibrils, right? Okay, so this requires 7 grams of this or 7 mils of this. They're almost equivalent in this case because this is mostly water, right? So let's do 7 mils of this, and the rest will be all the way to 100 mils with water, right? All right, so I have the 7 mils here, and I'm mixing it in with about less than 50 mils of water, right? Just to make it nice and smooth. And now I'm gonna pour this into the graduated cylinder like this and bring the volume all the way to 100 with water or betaine and calcium hydroxide, up to you guys. Just gonna use a rinse in my beaker and then bring it all the way to 100. And that's 100 mils. We can now transfer this to the beaker. And this is the desired concentration that we want, right? All right, so now solution is ready. I'm going to clean up a little bit and then come back, flatten the wrap, and then apply it directly to this area. How much of it, I really don't know. I'm gonna just try it out. Maybe 1, 2, 3 mils to this side and another mil to the opposite side, and that should do it, right? Let's give it a try. Okay, be right back. All right, guys, so I flattened it. And now I'm gonna be applying some of this stuff to this tear here. Again, I don't have methyl cellulose or starch, so I'm just using it. A mil of this goes here, like that. And nanofibrils are filling in the gaps here in the tear, right? Just like almost like administering furnish, right? And you could suck up the extra with paper towel, or if you have sponges and things like that, or if you have vacuum table, even better, right? You can see the fibrils are deposited already in the tear, right? So we probably don't need much, just like 1 mil here and another mil on the reverse side. That will do it. It's like administering almost furnish dust, except this is much stronger. Definitely stronger than Tengujo. Longer lasting, I think. And let's do this here. On this side, let's do this tear on this side. Can barely see it, right? But we'll do it this way. Here it is. And again, if you have a better way of getting rid of the excess liquid, do it, because they interfere with the volume you're adding, right? But this is the tear, and here's the fibrils going in, right? Pretty cool. And now all you need to do is tap it dry and put it in a press. Let it dry until it's dry, basically, right? So change paper towels and all that, right? All right. Okay, guys, so I brought it home with me and put it in the press overnight just to make sure that the cast is going to set. It looks pretty solid here from just looking through the, right? There's a little stickiness here because probably I got some of the cellulose, nanocellulose on. So you can see how it's like when you do anything that is sticky, it's going to stick a little bit to your Rime or Hollytex, whatever you guys are using. This is actually Rime. And I see where I added it. You can actually see the haze here. Let's look at the other side. Again, looks pretty good, I think, as far as sealing that tear seamlessly. No tengujo. You're using cellulose here. Not methyl cellulose, but cellulose. Pure nanocellulose is being used here to seal that tear, right? So the nanocellulose actually stuck to the Rime a little bit, right? So you have to be aware of that. This is one thing I noticed immediately. And as far as stability, the tear looks pretty good, guys, right? Tear looks like it's well taken care of. And I applied it to both sides. It's pretty nice and strong, right? And can I fold it without breaking the tear? Because the tear happened to be right in the spine area of this first wrap. It's foldable, right? Without any issues. Look at that, right?